Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Beyond the Edge. Exploring the Oort Cloud. In the farthest reaches of our solar system, beyond the orbit of the outermost planet, lies a mysterious and largely uncharted region known as the Oort Cloud. This distant and enigmatic cloud of icy bodies is thought to be the source of many comets that grace our skies, their tails painting brilliant arcs across the heavens as they journey towards the sun. The Oort Cloud, named after Dutch astronomer Jan Oort, who first hypothesized its existence, remains one of the most intriguing and least understood components of our solar system. The Oort Cloud is an immense spherical shell surrounding the solar system, extending from roughly 2,000 to as far as 100,000 astronomical units, AU, from the Sun. To put this in perspective, 1 astronomical unit is the average distance between the Earth and the Sun, about 93 million miles. The outer edges of the Oort Cloud lie almost a quarter of the distance to the nearest star, Proxima Centauri, highlighting its vast and expansive nature. The genesis of the Oort Cloud is believed to date back to the early days of the solar system, over 4.6 billion years ago. During this formative period, the solar system was a chaotic and turbulent place, with countless collisions and gravitational interactions shaping its evolution. The Sun and the planets were surrounded by a protoplanetary disk, a dense cloud of gas, dust, and ice from which the planets, moons, and other bodies coalesced. As the young sun ignited and the planets began to form, some of the icy planetesimals, small bodies that would become the building blocks of comets, were scattered by the gravitational influence of the giant planets, particularly Jupiter and Saturn. These gravitational interactions ejected many of these icy bodies outwards, far beyond the orbit of Neptune and Pluto, into what would become the Oort Cloud. Over time, these scattered remnants settled into a distant, spherical shell surrounding the solar system. One of the most fascinating aspects of the Oort Cloud is its role as the birthplace of long-period comets. These comets, which take more than 200 years to complete an orbit around the Sun, are believed to originate from the Oort Cloud. When a comet from the Oort Cloud is perturbed by the gravitational influence of a passing star, or perhaps by the tidal forces from the Milky Way itself, it can be nudged onto a trajectory that brings it into the inner solar system. As the comet approaches the Sun, the heat causes its icy nucleus to vaporize, creating the characteristic glowing coma and tail that we see from Earth. One of the most famous comets, Halley's Comet, is not a long-period comet but rather a short-period comet with an orbital period of about 76 years. It originates from the Kuiper Belt, a region of icy bodies beyond Neptune. However, many other comets that have graced our skies, such as Comet Hale-Bopp and Comet West, are thought to have originated from the Oort Cloud, taking thousands or even millions of years to complete a single orbit. The Oort Cloud's vast distance from the Sun means that its icy bodies are only weakly bound by the Sun's gravity. This makes them susceptible to disturbances from external forces. For instance, As the solar system orbits through the Milky Way, it occasionally passes through regions of higher stellar density, such as the galactic plane. These close encounters with other stars can perturb the orbits of Oort Cloud objects, sending them careening into the inner solar system. Despite its theoretical importance and the role it plays in our understanding of cometary origins, the Oort Cloud remains an elusive and unobserved entity. Its great distance and the small size of its constituent bodies make direct observation extremely challenging with current technology. No spacecraft has yet ventured far enough to reach or study the Oort Cloud directly. However, future missions and advances in technology may one day provide us with a clearer view of this distant region. The Oort Cloud also holds clues to the broader processes of planetary formation and the dynamic history of our solar system. The study of comets, which are often regarded as frozen time capsules, can provide valuable insights into the conditions and materials present in the early solar system. By analyzing the composition of comets, scientists can infer the nature of the primordial solar nebula from which our solar system formed. Moreover, the Oort Cloud offers a window into the interaction between our solar system and the rest of the galaxy. The gravitational perturbations that send comets from the Oort Cloud into the inner solar system can also provide information about the distribution and movement of stars in our galactic neighborhood. These interstellar interactions highlight the interconnectedness of celestial bodies and the dynamic nature of our place in the universe. The discovery of exoplanets and the study of other planetary systems have further broadened our understanding of how common Oort Cloud-like structures might be. Observations of distant star systems and the detection of exocomets suggest that the formation of similar distant reservoirs of icy bodies could be a common outcome of planetary system formation. These distant clouds could play a similar role in delivering volatile materials to the inner regions of other planetary systems, potentially aiding in the development of habitable environments. The Oort Cloud also invites speculation about the potential for life beyond our solar system. While the icy bodies within the Oort Cloud are unlikely to host life themselves, they may play a role in the broader context of astrobiology. Comets and other icy bodies can deliver water and organic compounds to planets and moons, potentially contributing to the development of life. The panspermia hypothesis suggests that life could be distributed throughout the galaxy via comets and other celestial bodies, with the Oort Cloud serving as a reservoir for these building blocks of life. As our exploration of the solar system and beyond continues, the Oort Cloud remains a tantalizing frontier. Future missions, such as the proposed interstellar probe, aim to venture beyond the heliosphere, the bubble of solar wind that surrounds our solar system, and into the interstellar medium. Such missions could provide valuable data on the outer reaches of the solar system and potentially offer indirect insights into the Oort Cloud. In the meantime, ground-based observatories and space telescopes continue to search for clues about the Oort Cloud's existence and its role in our solar system. The study of comets, both long period and short period, offers a direct link to this distant region and provides a window into its composition and behavior. By analyzing the isotopic ratios and chemical makeup of cometary material, scientists can piece together the story of the early solar system and the processes that shaped it. The Oort Cloud, shrouded in mystery and intrigue, represents the outermost boundary of our solar system. It is a region where the sun's influence wanes and the gravitational pull of the galaxy takes over. This distant frontier holds the key to understanding the origins of comets, the dynamic history of our solar system, and the broader processes of planetary formation and evolution. As we continue to explore and uncover the secrets of the Oort Cloud, we gain a deeper appreciation for the complexity and beauty of the cosmos. Whether through future space missions, advanced telescopes, or the study of cometary visitors, the Oort Cloud remains a beacon of scientific discovery and a symbol of our quest to understand the origins and evolution of our solar system. The journey to the Oort Cloud is not just a scientific endeavor, but a voyage of imagination and exploration. It challenges us to think beyond the familiar confines of our planetary neighborhood and to consider the broader context of our place in the universe. The Oort Cloud, with its countless icy bodies and potential for discovery, beckons us to continue our exploration, to push the boundaries of our knowledge, and to seek out the wonders that lie beyond. As we look to the future, the Oort Cloud stands as a frontier of discovery, a realm of endless possibilities waiting to be explored. It reminds us that the universe is vast and full of mysteries, and that the pursuit of knowledge is a journey that never truly ends. With each new discovery, we move closer to understanding the nature of the Oort Cloud and the role it plays in the grand scheme of the cosmos. The Oort Cloud, distant and enigmatic, remains a testament to the enduring spirit of exploration and the boundless curiosity that drives us to seek out the unknown.